Hi, this is Abdul Aziz Khan with another video after a lot of time because I am a bit busy these days. So I will not try to shorten the video. This video may be a bit longer. Uh, in this video, I will try to introduce you with two, three different links and we will discuss that what is the difference between these links basically. Because I have seen a lot of people planning and they don't go in a bit of detail. If you are experienced planner, if you are familiar with the area, then okay, you may have some intrinsic knowledge that you learn by mistake or you learn by time. But if you are doing planning in some new area, the area is not very much known to you, then at least in the initial links or for the initial time, I mean, you should be a bit careful. You should go and see something more than just planning a link. We will see three links in three different type of regions, and then we will try to see that what are the main differences. Apparently, all the links should look like the same to you. Let me show you a bit. Like for example, I have chosen this one link. This link, if you can see it, it's between two peaks. So this is one scenario. The other scenario I have is this link. If you see this link, this is a kind of plain area. The height is not too much and both sides are almost on the same height. And the third link is on crossing the sea. So if you see this link, this is crossing a small sea area. I could make many more scenarios, but I try to keep the length the same and I have tried to keep the equipment also as the same. So let's just go and see these links one by one and let's see. First let's see. You see this is a link almost 42 kilometers. It's a 6 giga link. The antenna is too much big. It's a 42 kilometers, so I put a bigger antenna. I put very normal kind of radio. I mean, this radio is of 6 giga, only 8 evens, not too much. And all the other factors are normal. C factor is 2. I have taken the rain region, same ITUP region everywhere, so that I have tried to take the main things as the same. So here you can see that the link is not affected by rain at all. The annual rain is 100. And it's also a good link. I mean, you have 6 nines. So 6 nines means you are very good. I mean, even though we are uh, crossing the sea, still the link is showing that it's fine. Now this was our second link. This is on a plain area. Now here also you see that I have taken a bit smaller. Let me take a big dish because I want all the links to be same. Okay, so I have taken a bigger dish now, so it's has 100% rain availability and it also has 6 nines. You see we have this typical rain P region. The C factor is here also, it's 2 and it's the same radio, 8 evens, 6 gigahertz. So what I want to show you up till now is that apparently everything looks same. I mean that okay, we can do I mean, what is the difference between the regions then? What is the difference between the places if everything is same? So here again you see that I have this again is small. I will change this one again with the 15 feet dish. Okay. Okay, so now dish is the same. The radio is again same radio, 8 evens. Climatic factor is different. I cannot do anything because it depends on climate. But one or two, okay, there's a difference, but okay, not a big difference. I mean, as we will see that the rain factor is again same, ITU region P. This is also giving us a rain availability of 100%, and this is also has 6 nines. So the question which comes to me, which should come to everyone, that okay, if this is, I mean, what we saw, if it is what is what we experience, this is what happens. I mean, if in actual, if all these links are exactly the same, then what is the difference? I mean, why should we bother then? We should just plan the links and we should just go ahead. I mean, so let's go a bit in deep now, because now let's see that we'll go in some kind of detail. Let me start from okay, from the top, from the north. Okay, this link looks fine. Let's go in the antenna heights and let's put the minimum height. This height is a bit higher on both sides, but you know that this is because of these peaks. If I put my antenna on these two peaks, I put one antenna here, then I don't need any antenna height. I mean, this will work fine. I have not gone inside and picked the right candidates. I mean, I did not spend a lot of time, but just to show you that here the height is only dependent on the line of sight, because nothing else is going to stop you from using these heights. One more thing that we should try to check in all these kind of things is the multipath. So for the multipath, if I start, because the problem is that one side is I have chosen very low point. Now the best thing you see is that there is no multipath. Even if I had put the antennas here, I can assure you that still there should be no multipath because of these peaks on the receive side. These two peaks, they will not let any multipath reach on this point. And if even if you assume in your mind, and if you reverse it, generally we have to reverse the profile, and then we need to see from both sides. And let me show you from the reverse side as well. This will give this problem again and again. Hmm. Basically, I should have chosen the, but no problem. You can see from here as well. No multipath will reach here. I mean, if you have a clear line of sight now, like on that side, these two peaks were basically on the reverse. These were on the other side. Now, here also we have some peaks, small peaks. That's why whenever you talk to any experienced guy, he will tell you that planning a link in a hilly area is a piece of cake. I mean, because you just have to take care of the rain only, because rain is the only factor, and other factors are there. I will not say that other factors are should be fully ignored, but because of the terrain you have in between, rain becomes the only significant factor, because all other factors, like the main factor that makes your link work badly in any sunny or uh, winter day is the multipath. And multipath has almost no effect in a hilly area like we see here. So let's go in our second case. So this was our second case. Looks like very simple, but one thing that you see here, this is the required antenna heights. Now, like for example, in the hilly area, I had shown you that we can use um, we can use different. I mean, I can plan a link on a good towers. I mean, I can plan good location for my tower, and I can reduce the tower heights considerably very low. I can reduce the tower height to be only 5 meter. We can just put the dishes on the ground even, and we can make a link. And that was a hilly area. But here you can see that this red, this is your earth bulge because of I will not go in very much detail right now, but this, the yellow one is the normal earth. This is the line of sight. I mean, this is the visible earth, and this red is the earth which is seen by the microwave link. So we can see that from here you can see that if I put an antenna here or at this point only 10 meters, and I put an antenna here, both of these antennas will be visible to naked eyes. I mean, you can, if you have a binocular and you can see uh, 42 kilometers, uh, then you can watch the other antenna. I mean, you can see the other antenna with your eye. But if you will put a microwave link and you to put a tower here and you put a tower here, then there will be no transmission for most of the time. Your link should have very big fluctuations. It will not be working perfectly. At least the day and night should be, I mean, either it will not be working in the day or it will not be working in the night. It will be giving you all sorts of problems. The minimum antenna height suggested is this antenna height, 60 kilometers one side and 50 kilometers other side. So, and if we take the multipath, then we can see that the multipath is not a big issue here because even a normal rough terrain also, this is not a smooth terrain. I mean, if it has been a smooth terrain, then this could also make some problem, but because it's a rough terrain, so multipath is not a big factor here. You are fine for the multipath, but the big factor here is what I show you is that if you will believe on your visual line of sight. For example, if you send someone and he told you that I'm sitting on the ground and I'm standing on the ground and I can see the balloon on the other side. So we don't need any big antenna, and you put only a 20-30 meter antenna and on the both sides, and you get a line of sight, and you just pan the link and plan the link in a normal sunny day. Then this link will be starting giving you problem in the night time. So this is a catch that I have found on many places. People, they have put links in from here also you can see that from this picture it looks like a very smooth terrain to you. I mean, not big problem, no line of sight issue, no other issue. So just put antenna on 10 meter and start doing something. But as I showed you that this will not help. You will have to put the antennas at least 60-70 meter high. And again, if you go for some kind of general recommendation, you will need 1 plus 1 standard. You will need 1 plus 1 space diversity as well, because what I show you, I will not go in too much detail, but uh, this thing that you are watching here, this thing can become a nightmare for you, because you know this does not remain constant. This picture is depicted on um, a normal value of this k. Like for example, for 99% of the time, it should remain on point 0.9. But this picture, generally path laws build it on 1.33. It's not on 99. So 1.33, k is 1.33. It should remain almost 60-70% of the time. So it means 40% of the time your link should be in big problem. So you need to plan this link more carefully. Either you need to take the antennas more higher, or you need to plan it with a space diversity so that the link tries to keep working all of the time. So this link, it looks very simple, but it's not that simple. The third link that I will show you now, here also you can see that this link is going over this water area. This area is fully flat. But I think I don't have chosen, I should have chosen a place where the water area is much more. Because here when we will go in the multipath, we will not find, I'm sure we will not find a big issues, I mean, because it's almost in the center. So yes, we can see that if we put this link the other side higher here, somewhere here, then this multipath will become a problem for us. Currently, if we see, the dishes are on 44 and 64. Okay. If I reverse the profile and I see it again, from this side, this place is a bit safer because of some things here which are not allowing this. So I have chosen a bit wrong, or bit I have chosen not a perfect place. Uh, Let me spend some more time here. I should take it on a more difficult place. Now, now I have taken the side, but still I don't think that hmm, still the multipath will not affect it. Hmm. No, still the multipath is not affecting. No problem. Let me move this to. Okay, the link should be shorter, but now this link will be in a big issue, hopefully. Okay, as the link is shrinking, so Uh, I need to do the profile again. It's okay. Now the link, from here, because I have shortened the link a lot. The dishes are too big. But the link has exceptional great values. But let's see if there is a difference on the multipath or not. Now we see that there are big reflection points, and now you see that the other side is gone in the multipath area. So if you have a water body in between, that's why we say that you should avoid a water body. So you see here that we are on very low antenna, 30 meter and 30 meter almost. And we cannot lower antenna further, because if we lower it, then the earth bulge, the K factor, should start hitting it. And as the multipart tells us that even at this place where we are sitting right now, we are in the danger zone. And if I reverse the profile, then even the reverse side. So you have a problem on both the sides. This is what water can do with you, I mean. So apparently you see uh, that the link looks fine. I mean, if you just plan the link in this way, that you don't see anything else, you see these numbers and you are very happy. Oh, I have planned a link on 100% of everything. But when you will start, if you will implement the link, then you will come to know that the link has big problems, and that time you will be astonished. You will be thinking that, okay, what I did wrong, I mean, why this link is having this much big problems. So I hope this video should be a good learning point for you. We discussed three scenarios. One was very flat terrain, and no any water body or any problem in the terrain, but still we saw that even with a flat terrain there are issues. You need to go very high, and the flat terrain is, and even though that train was not flat, basically that train was not some flat train, they are really flat, I mean, but that the flat train that we saw, that flat train has the terrain was not uh, it was not smooth, I mean, the train has a lot of ups and downs. But generally it was looking like a very flat train. And the real flat train that we see, that was on a water body, we saw that the water body has its effect. It's not easy. Again, if you are working on a water body and you must uh, plan a link on it, then it's better that, again, if you use a space diversity and try to keep one antenna out of the problem. If anyone wants to plan a link and he wants to plan a link on a water body, then he should go in more detail of this, like he should uh, see that what are the exact places where he should put his antenna. Just putting an antenna on some, what I can say, putting antenna on some place where you feel that the direct and the indirect don't meet. Like, for example, if you just use this picture and you say that, okay, I will put my antenna here because the reflected ray is not coming here, it should be a wrong interpretation, because this has a limitation. I mean, if it is showing one incident coming here, one here, one here, then do believe that there are incident rays in between as well, because path loss will never plan exactly all the rays, because it will be a whole red colored diagram. So it makes a ray on different degrees only. Don't take all the degrees in between. If you really want to plan a link at this kind of place, you need to go further, and you need to see that how you change the position of one antenna in relation to the other antenna, and you need to plan it as a 1 plus 1 space diversity, and then you need to plan the space diversity distance between the links. I have already one video, that's why I'm not going in detail here. I have already placed a video. If you are not able to find it, you can comment and I will show you that video, from where you can know that how we plan the distance between space diversity antennas, and the path loss gives us a very big help for that. So it is not easy. The easiest link that we saw in the first was a link in a hilly area. The only problem in a hilly area is that you must find very appropriate peaks. If you have very appropriate peaks, then you even don't need any kind of bigger tower. Only 5-10 meter tower is enough. A line of sight in a hilly area is a real line of sight. Let me show you that one again, once again. Just I want to emphasize on one thing here. You remember, you see this here, the effect of this dn by dh, or the k value, is very minimal. You can see that the optical line of sight and the line of sight for this wave, they are almost on the same path. You cannot even see the difference between this red and yellow line. They are almost in the same place. So this is the beauty of the hilly area, that they are like, you can see very easily that if I put one tower here and I put one tower here, then I don't even need any antenna height. I mean, everything else will remain the same, and this will become a perfect link. I mean, and you can plan this link with a very very high capacity as well. So I hope this video was a good learning. And if you have any comment, if you need to know anything more about anything that I discussed, then we can I can make another video for you. So see you next time. Goodbye.